Hey guys, I've got an update on my game Saturn 7.
So hot.
So the distant hills in the background, you can see they're nicely updated. I got a AI website to do that from a base template that I had. So that's a nice addition. I always wanted to add the background hills to give it more detail into my scene. Actually, it looks a lot better. The only problem is getting the clouds to line up behind the this skybox. It's all skybox driven. Tends to look better than a sky dome for whatever reason in CopperCube. I'll just switch on my cover. So I've got an ability to detect cover and change the rain and weather particles accordingly. I've got sun cover, affects the temperature of the player, and then the wind as well. The closer you are to wind cover, the more alpha, so it goes almost to zero. The more exposure to the wind, it gets more intense. It's like that, yeah. Yeah, so that works alright, and that, of course, always adjusts all the stats of the player. He's a bit hot at the moment. Let him get a bit cold in the. Needs a bit of wind and a bit of rain actually to cool down. So I've made this game so you've got to interact with all the weather, the terrain to get out of the sun or get in the sun depending on the weather, or get in the weather or get out of the weather depending what temperature of the player is. And so that rain particles, all the particle system I've taken out of my other behavior that I made before. So you can see it's got impact, pretty mild sort of impact. I probably should make that a little bit brighter. And it's got, see the wind effect? There's a wind effect as well, and that changes. It's using my crossfade material to transition from a standard terrain to the rain sort of effect, the bluey sort of colour of the rain and the wind happening at the same time. On top of that, I've got a ability to change the terrain colour and specularity as well, actually. So it's very subtle, but it's actually there. It's happening, so all these things are going on. So yeah, there's the that planet needs a bit of work. So yeah, all those background hills, it's all skybox. The actual planet now is a skybox. The sun is a skybox. It's all skybox driven, so that I can have them all layer one behind the other properly. The only problem is when I'm adding in the clouds. I've created a new cloud scene node that I wasn't able to get working before. I have got working now, but I'll show you that next little bit. But the only issue with it is it will go on top of the skyboxes, overlap over the skyboxes. The clouds won't go behind these hills here. It's very good, but if you're using distant hills like that, you can just make the distant hills a lot lower, and it'll look alright. Then it'll be okay. But these ones are really high, so I'm not sure if I'll using the cloud seed node. But anyway, so the wind particle effect is a specialized one I've got working, created myself. It fades in and it fades out. It finds the impact, does a collision check on whatever it impacts on the line of collision that it's traveling at, and then it will fade out proportionately just before, back to full transparency before it hits the object. So and you won't see it pop in the distance. So it'll fade in, go, and then fade out when it hits just before it hits the object. So it looks pretty good. Yeah, got some of the other stuff sort of working. That the meteorite's not fully working properly yet, but sort of working partially. Yeah, so yeah, a bit of an update. So a lot of recent additions to the particle system I've added. So what I've done is, instead of cloning endless objects and then deleting the clone every single time, I've sort of reused a batch. So I create a batch and then I make them invisible and hide them until they're ready to be reused again for a different particle system, like now is the meteorite system. Yeah. So it looks a little bit weird at a distance, but I might do some work. I'll have to do some work on that to try and fix it up. Yeah. So, and you can see the wind effect has changed the particle to a black sort of black sort of a wind, and that'll fade in and fade out back to the original one over time. And I'm under cover, so I've got cover. All I do is I select a scene node with certain dimensions, and that goes into the the weather action. So I've got a weather action and a wind action, and they only work when I need it, and they're just not working when I don't need it. So that's good like that. Yeah. So I'll just get through that. As you can see, there's no wind coming through. Thanks, Tom. There's no wind coming through this shelter here. Oh, what have we got here? Getting really dark. What's going on? Must be. What's that? Oh, it's getting dark late at night. Okay. Yeah, I mean, these are all just basic setups to start with. I'll need to do some more work to it later. It's getting too dark. Anyway, so that's a couple of quick updates on my game. Okay, I've also got a terrain coloring API that I created, where it can change both the ambient color or specular color and shine if ever need to. Normally you wouldn't use it much, but I've got a rain effect in my game, and I was wanting to change the surface of the terrain to sort of match like a sort of a wet shiny look. I mean, it's not perfect, I couldn't get it perfect, but it is something I got working. Anyway, so this is how I've used it. I can either just change the color straight up, you know, something like that. That's obviously too much, but it's just an example of the ambient color hasn't changed too much. It's gone a bit darker, but the specular color is quite high, maybe a bit too high. Or you can just fade it in and fade it out. So that's really what I wanted it for. So you can see that over time you can fade it in, fade out, whatever colors and amount of shine to give whatever effect. That the specular part does give it a type of saturation and shine effect, a bit like being wet, I suppose, a little bit like that. I'm not saying this is the perfect setup, but you know, you can change, modify, play with the colours and adjust it how you like. But this is just I've exaggerated it just so you can see that it works. Fade it in, fade it out again. So that's nice. And that's in my game now. So when it rains, it sort of has this little bit of a wet look to it. It's not like Unreal Engine 5 or anything, but you know, it's something. So this is the API, set terrain color, put your terrain node in, then this is the ambient colors here, RGB, and this is the specular colors here, RGB, and that's the shine amount. If the shine amount's 10, then specularity is automatically just turned off. So no matter, regardless of what colors you put here, if it's 0, you're not using specular shine. But if you put anything other than 0, it will. So there's the ambient RGB, specular RGB. And the shininess, normally about somewhere between 0 and 20 for shininess typically, and on average it's like 10, 15 is probably a good number, somewhere there. There's a couple of other additions that I haven't mentioned before that I've got now in the APIs. There's get texture list, that gives you a list of all textures in memory. Okay, I've also created a dedicated load texture API, so it's pretty much as normal. Put the actual location name of the texture in, something like that. But this has got some additional things that's never been added. So I've got here the quality, between 0 and 2. 0 is actually the highest quality, 2 is the lowest. 0 will always be 32-bit. If you put 1 in, that will use the the quality of the texture that was created in. Could have been created 16-bit or less, but it'll keep it, generally speaking, at that format that the texture is created in. If you put 2, it'll change it to 16-bit. This really only affects memory usage. If you're really worried about memory usage on lots of huge textures, maybe you could give it a try, changing the quality to 0 to 1 or 2, see what happens. I haven't actually tried it yet, but it's all set up, ready to go. And the main thing here is bitmaps. You can tell bitmaps, you want bitmaps or not while you're loading the file. So for like terrain system or anything in your level that can be seen at a distance, then yeah, put true as bitmaps, of course. That's the default, is always true. But if it's like a GUI interface, a screen, image on the screen itself that doesn't have that distance thing, then you would put false. You don't need bitmaps for that. So that's a little bit better. So more control over your texture loading. Yeah, and now with the terrain, I've changed the name of this one. When you're doing a single texture update on the terrain, I've just called it set terrain text single. It was a slightly different name before, but anyway, it works the same. So you got via angle, via height, or a single texture at a time. The single texture at a time will utilize both the height adjustments and the angle adjustments, so it's quite good actually in that way. Yeah, here's a new one I just forgot to add. Get terrain height. This is actually very good. You put in any X and Z coordinates with the terrain node, and it gives you the exact vertical height. So if you're doing like, could be you're throwing an item, you want a collision to the terrain, or anything like that. Could be particles system or whatever. Lots of reasons you might want to run this query to get the exact terrain height. So in the vertical from the X and the Z coordinates. Yeah, it works pretty good actually. I use it for my particle system. So yeah, sometimes I need to use that. Yeah, so that's it works really well. It's much faster than standard triangle collision. Like the player's walking around anywhere, it's checking all triangles on the entire level. But with this method, it's heaps faster. It only just looks at the cell, the very local area that the player's in, to get the triangle and then the height from that. So so that's really good actually. It works really fast. Very good for performance. That's the best way to get something on the terrain height actually, this method. Yeah, so that will just give a single output. Returns the height of the terrain. So yeah, yep, so that's that as well. So that's pretty much all my recent additions. Terrain color, terrain height, yeah, load texture. So I put that in because some images I don't need bitmaps and some I do. So I thought I'll just put it in per load as I'm doing the load. I'll put in whatever I need. I might even make this a variable, the quality, so someone can theoretically change the quality of the game if they've got really low memory on their computer for some reason. That'll help with the reduced memory, because by default it'll be 32-bit, which is, if I understand that correctly, that's 4 times the size, not just twice, I think it's 4 times the size of 16-bit. Pretty sure. Yeah. So yeah, so that's just something they can use. Now there is another one called set sRGB as true or false. This is a new DirectX, well, new for me, but it's been in the engine for a while in Airlicht. But I've just recently added it to CopperCube. You can actually change the sRGB color correction for gamma and contrast. So in other words, it automatically adjusts both your contrast and gamma levels to look more realistic. It's made to look more realistic, so no excessive saturation, and that's That's something I've been trying to fix for a long time, and that might be good. But the thing is, you can't save the textures that you're using it with in an sRGB profile. It's actually a type of profile, yeah. So let me test that out, and we'll see it in the next video. Okay, so here's an example of the cloud scene node. This was created by a fellow in the Irrelict forum, TBW. So thanks for that, whoever TBW is. So we've got a sample. I've managed to get it into the CopperCube. This is not Irrelict, this is CopperCube. So you can see the cloud layers. There's actually 3 layers there. High, medium, and low. That's all working. And you see in the distance, it has a very nice fade out. It fades out. It's using Vertex Alpha to get that nice fade out in the distance. You can't even see where it's faded out. So if I change the lower levels clouds, I can change the angle and speed like that. You can change a lot of things in this new scene node type. Actually, it's quite good. So basically, I've created a new API to run the code. It's called CCB Get Cloud Layer. So you can have as many layers as you want. I've got 3 layers here, and each layer can have 2 different textures. The default setup of the way it was set up originally is not to have any dynamic lighting. It uses a material called one texture blend. There's no dynamic lighting for that, so lighting is turned off. But I've got another setup. You can actually use dynamic lighting. So this is something extra I put in, and I've used my new material. I've just called it solid crossfade, but actually it's transparent as well. So that's crossfades between 2 textures. You can fade one texture in from one to the other and backwards again, or whatever you want. So not only the transition for 2 textures, but also the transparency as well separately. So that's a nice texture to use. I would like to use. That's what I'll be using in my game. But the one texture blend is a special setup that uses the Vertex Alpha to get the nice blending in the outer radius. It's a dome with 3 sections. You've got a central color, an inner color, and then the very outer. So that's 3 parts. And this is the alpha here, 200, 110. So that's what changes the alpha. So it blends in nicely from a distance. When you're using dynamic lighting, you can't. I've had trouble. It doesn't work with Vertex Alpha so much. I mean, theoretically, you might be able to create a material that does everything, but my material, solid crossfade, is not designed for that. It doesn't really need it, and you get nice results anyway without that. So what you do is you set up the cloud layer using Get Cloud Layer. You create a variable, and then once you've got that variable, then you can go and change any of the properties. Like you've got all sorts of properties. I'll just show you here down the bottom. You've got inner radius, outer radius. That's the size of the dome. Cloud height. That's a vector 3D. So the outer, inner, and central. It's in three parts in a vector 3D. Center color, inner color, outer color, ambient color, and emissive color. That's for dynamic lighting. It won't work with Vertex Alpha. Then you've got texture index, which is normally 0, but if you're using two textures to merge from one to the other, you may need to use that to then transition that number over time. Then you've got translation, X and Y coordinates. That's vector 2D. I added that into CopperCube from 1.8.5 version of Irrelict. It wasn't in CopperCube at all before. It was a bit of work just to get that in there, but anyway, that's working fine. And texture scale. So that's how the scale of each texture. So they're your main things you can change. You can have 1, 2, or 3 layers or more if you want. Yeah, it's quite good actually. It's a nice little system. So I've shown you the first one. So false. So you add the name of each texture. You can just have one texture and put blank in the second one if you want to, or you could add an actual texture. Either way, it'll still work. And here false means dynamic lighting. But if I change that to true, change all of them to true to dynamic lighting, now we'll get access to ambient color and emissive color. So that'll give you better control over the color. Actually, the vertex colors don't seem to work that well. I'm not sure why. I haven't worked that out. There's some limitation the way I've set it up. And the material, one texture blend. I had to modify the one texture blend material because it wasn't working quite right. Anyway, so with the now that's dynamic lighting is turned on, it will then access my other setup. So it sends through the lighting as a boolean, true or false, and if it's true, then it will turn lighting on and use a different material called solid crossfade, and you can cross fade from one texture to the other. That's actually really nice. I'll show you that now. Okay, just for testing purposes, I'm adjusting the ambient and emissive color of cloud. I'll make it number 3, the lowest cloud. The top is, I've just set up the top one as the first one. Then there's number 2, and number 3 will be the lowest one. So I'm adjusting the ambient color. You don't need to set up a vector 3D and just put in, you can just put in the actual colors directly. So it's got 3 inputs there and 2 there, so that's 5 in total. Same with the emissive. Yeah, so that works fine. Okay, it always starts at night time, and just is my little test. Okay, so the lowest cloud level, those little thicker ones, down the bottom they're getting orangey color. So I could adjust all of the clouds if I wanted to easily, and this is just a test demo, so you can see it working. Where's the sun gone? There it is, coming up there. Anyway, so the idea is you can change it to whatever color you want, whenever you want. I actually found a little bit of emissive, and the actual color comes from the ambient color works best. And just adding a little bit of emissive, like, I don't know, 10 or 20, so 10, 10, 10, or 20, 20, 20, plus the ambient color seems to work the best to get the color you want. So yeah, that changes the color over time as the sun rises. That's the idea. So that works. I can change the direction and speed. So watch the lower cloud level. Now it's changing direction and speed. That's using a vector 2 that I added into the engine. Now this is dynamic lighting. The main difference between the two, is that in the distance, the dynamic lighting version using the other material does not blend the far distance nicely. It's a bit hard to tell right now because there's 3 layers all working together, but if you only have one layer, you'll actually see where it cuts off, cuts in and cuts out. You can, when you're down in the bottom, walking down in the ground, down in the valleys, you tend to not notice it because it's below the horizon, so it's sort of covered up, but that's the only weakness with it. It doesn't blend in distance properly, but other than that, it's pretty good. So I have it all set up before first drawing do something, set it up there and just have it set up, run. So you need to just set it up first, you activate it, get the node, and then you can change the properties. There's cloud height. So it starts with the inner dome, the outer dome area, and then the far outer edges area. A negative means lower than 0. It means closer down to the ground, in other words, compared to. So if you put 0 there, it means, I believe it's basically the same height as the previous one. But if you put negative, it'll actually be lower. So it'll be more like a domed effect. But you can. Yeah, so you can see how these are the common setups that TBW has in his basic file defaults. Then 0.4, then 0.35, so it gets lower, each level is lower than the other one. Translation is X and Y coordinates for moving the texture coordinates. It's just translation. I've modified this code, I've simplified it a bit. So cloud height used to be in 3 parts, 3 different variables, I just put it all into one. Translation used to be in 2 variables, I just put it into one as well. So I just added in the, it's now 2 inputs. You never could do that with CopperCube before, but now you can with a vector 2D. I added all that code in, and that's working, which is good. Texture scale, yeah, so the lower the number, it makes the texture scale spread out over a bigger area, in other words. Yeah, so the higher the number, the more copies of that in a given area, in other words. Yeah, so, and that works really well. Now I'll show you if you use dynamic lighting, there's a nice little thing you can use to merge between two textures. I'll show you that. That's very nice. You can get all sorts of nice effects with that. So that's the API, set crossfade, get the cloud node, which is in this case is actually 1. Make it number 3. Yeah, I'll make it number 3. That's the texture index, which is normally 0. This is the transparency, which I'll just have full transparency. So more than 0 means additional transparency from what the ordinary transparency already is. In other words, so when that goes to 1, it's fully transparent. You can't see anything. And this is the blend amount. So I'm going to change the blend amount, which probably should just call blend, not cross fade or blend or whatever. So up to 1, between 0 and 1. And I'm also going to be changing the texture index, because to continue to see the cloud moving in the sky, you do need to update that into, so as it gets over 0.5, it'll round up to 1. So then you'll need to run this bit of code so that the clouds continue moving in the sky, because the code, I modified the code to do that because I had to have it that way. Okay, so on animate, this gets run on every frame before it renders that completed image after the animation or movement, and it needs the get texture matrix, the texture index. It's normally 0, but as you transition from one texture, the first texture to the second texture, that'll go from 0 to 1. So it can continue working. I'll show you that now. Okay, so I'm going to adjust texture layer number 3 from cloud number 3 to cloud 1B, and all these have to be under data images. That has to be in that order. There's 1B there, so that'll go from there to there. Okay, so let's do that. Okay, so there's the lower level. Clouds are going to transition from one cloud to another. It's a bit rough because I'm doing big jumps, but normally you would do it in a smooth way. It would be nice and smooth. I'll just show you now. Slowly but surely. Oh, a little bit of a jump there, that's alright. Transition to the next texture. So yeah, so that lower level is actually a different texture now, and it's transparent. Everything works nicely. Yeah, it's quite good. Obviously the clouds are above the horizon, but when you're down walking in the ground areas, it looks like it's below the horizon anyway. It's just because I'm up on a high mountain, you can sort of see where it starts and stops. That's only weakness. The non-dynamic lighting version using one texture blend will nicely blend the far edges using vertex alpha. So it'll blend out over time. So it is nice in that regard, but this dynamic lighting version is better in the sense you can much better control over the colors and everything else. And notice how I'm using far plane clipping. See the mountains clipping in and out, but it doesn't clip the clouds, and that's the whole reason I really had to get this working in CopperCube, because I really want to make use of far plane clipping in my game. So I could almost have an unlimited size terrain, well, sort of, and with far plane clipping you can just have a certain cutout. So you've got frustum culling for 1, then you've got far plane clipping for 2. That cuts out large chunks of the terrain. You only need to see what the player's seeing in the camera. And on top of that, I could add occlusion culling. That's a 3rd layer. That'll be even better for performance. So that'll work as well. It does work. So that'll be really good. Yeah, so you can add even higher size terrains if I wanted to. Yeah. So when you're down low, you don't see where it cuts in and cuts out. It's just not a major problem. Yeah, so that's pretty cool, isn't it? You can fade textures in and out, so a different blend amount over time, but also the transparency is a separate thing that can fade in and fade out too, as a separate. So parameter 1 is transparency, parameter 2 is the blend amount. It's not really blending, actually, it's not the right word. It's a fade, crossfade. You're actually reducing the first texture and increasing the second texture over time, or vice versa. I guess it's a type of mixing, you could say. Yeah, I suppose it is a type of blending in a way, partial blending. it's never fully blended. It's not just changing the transparency and mixing the two together. No, it's not that. It's more than that. So yeah, that works pretty good. Yeah. Now I found those who want to alter the source code, probably not many of you, but there's a couple. You'll find that adding in new stuff into CopperCube from Irrelict or wherever else is actually a bit of a pain, especially when you adding new include. So I haven't got the. So you have normally all these include type files, but when you go into Scene Manager and include, it could be anything like. In this case, I've actually made use of empty seam node, which is already part of CopperCube. I've just thrown it in there because it was almost impossible to work out what was not lining up. There's all these changes over time, quite a lot, from CopperCube days to the modern Irrelict 1.8.5. A lot of changes, and you'll have all these problems, things not lining up, and then ultimately it'll be a linking error, and it'll come up with some ridiculous, almost unreadable message like this. It'll go through all this sort of almost nonsensical error message. There is some logic to this madness. You can actually see it there. It is that set attribute, get attribute as vector td, get attribute. That actually is the problem, but it's not very clear at all. And it won't tell you the line number. No, that's not right. It won't tell you the file either. It's actually in this message here. But anyway, you'll get all these problems unless you do it. A workaround I found to get away from these ridiculous error messages. Visual Studio is actually an excellent program, but sometimes it can't find the problem, or it doesn't explain it at all well. Like here, it's just terrible message. I found an easier way is to use an existing system set up in CopperCube that works, which is called an empty scene node, and I just threw all the code in there. I can always restore it later on with the original stuff, but no one uses empty scene node anyway, so I made use of it. And when I put all the code into the empty scene node, the header file and the .cpp file, all the correct error messages would come through telling me this doesn't line up, this function doesn't line up with this, doesn't line up with that, and then you make the adjustments that way. Then I could actually put it into the system. Theoretically, now that I've got it all working, I would take it out of empty scene node and put it into its own, what was originally called this C cloud scene node. It's a completely new node system in the engine. I mean, theoretically I could do that. For now, I don't need to. But yeah, in the beginning, it was impossible to get it to work almost. It was so difficult because it would have these error messages and it wouldn't explain where the problem is properly. To go through it, you would have to go through every single function and check every single time a function was called and go through all the linked include files to make sure they're all in the include files. And that was the problem. It could have been that, or a syntax error, or all sorts of things like this. So it's not just the name of the function has to be there, but the actual syntax has to match exactly as well. All these things just makes it a bit of a headache, I'm not going to lie. It's not easy. So I had to make a lot of changes. So the original file format was different. I had to make changes all over the place. Eventually got it to work. The original file had all these adjustments, newer adjustments that didn't work with CopperCube, so I had to change it, like texture wrap U, texture wrap V. Well, that doesn't exist in CopperCube. It's just standard texture wrap. So that was alright, didn't need it. This was ECF never, doesn't exist. It's just in CopperCube, it's just false. Things like that, all these little changes. All these upgrades, if you like, that don't exist in CopperCube had to be modified to suit, basically. So I eventually got it to work, and then I had a linking error that I couldn't work out until I made use of the empty scene node. Then it would actually tell me exactly what the problem was, basically. There was a linked file called matrix4, something like that. The name of the file was just slightly different in CopperCube's version versus Irrelict 7.3 I got it from. The file name was different, so I had to change it. But after that, it was alright, amongst a couple of minor adjustments. So this is one of the most difficult things I've ever done in CopperCube. This is much harder than me putting in the occlusion culling system into CopperCube. That was about half the work actually. I found this to be particularly hard. Anyway, so after all of that, making a lot more adjustments and simplifying the code, I got it down to a lot less variables. Can't clone cloud layers. Don't clone it. It won't work. Just set up new ones or delete it. Yeah. So now we've just got these basic variables here that you can change, which is pretty cool. Everything's working. No issues. So with the crossfade material, it's probably easier if we just use my API, set crossfade, put the name of the node, and then index, texture index you're talking about, and then the transparency and the crossfading amount there. Yeah, I mean, theoretically you could also do it this way, just set scene node material property, name of the node, index 0, param1, which is just param, and then param2, the same thing. That'll still work. This is a little bit easier, frankly. It's just a one line. Yeah, that works pretty good. I finally got it to work. So the whole idea is I can have far plane clipping in my game and have it adjustable and dynamic. Even I might even have dynamically adjusted automatically to maintain a certain frame rate. Actually, that would be really good. I can do that. So I mean, the cloud system is good but not perfect because it doesn't go behind the skyboxes. It'll go over the skybox. The only thing that you can make to go behind the skybox, like these mountains in the distance, is another skybox behind the hills, if you like, which is this one. There's the background. If you want the clouds to go behind that, you would have to have a transparent sky and then put another skybox ahead of this one, above it, the clouds, so that it can render that first before the hills, and then you'll see the clouds go behind the mountains. But I found using a skybox doesn't look very good with clouds. Not particularly good, no. Because it's a square box, you really can't get the same effect, like a sky dome effect. I just couldn't get it to look good, especially if you're changing the texture coordinates. If it's fixed, yeah, it'd probably be alright, but because it's changing all the time, I don't think there's any way you could really get around that very easily to make it look like a proper sky dome effect above the player, because it's a box around the player. Yeah, that's just not going to work very well. So anyway, so that's why I've made use of this new cloud scene node, because it draws it between the, here it is here, camera get near value, camera get far value, halfway between the far plane start and far plane clipping end. So it's, in other words, it doesn't get clipped by the camera view distance. So that's good. Same with the same with skyboxes have that effect. Sky dome, that also does the same thing. Yeah. So those I really wanted to have the background as well as the all the background images not to be clipped. Obviously the sun, the far mountains, the sky, the clouds, stars, all that sort of stuff. I don't want to clip any of that. I only want to clip the terrain. So that's why I've used that, and it works really well. Pretty happy with it. Yeah, so I hope you like that. Let us know what you think. Cheers.